So this is the same example we just saw on the slides that demonstrates the different scopes of variables uh, and the different storage classes, some new, some old. Just to walk you through this again, we have a global variable over here, which has file scope, declared and defined outside any function before the main function. We have the main function. Inside the main function, we are defining another integer variable x, this one initialized to 5. And the scope of this variable is the main function. We have a third integer x initialized to 7 in a new scope inside the main function. This is also referred to as the inner scope, meaning we are calling it the inner scope because it's inside another scope, that of the main function. And of course, we print out x inside the main function before entering the inner scope, before defining the third integer x and initializing it as 7, printing that out. And we print out the value of x after we exit the inner scope. And that is followed up by 6 function calls, 2 to each of the 3 functions whose prototypes we gave right at the top. The first one is called use local, the second one was use static local, and the third one is use global. So after these 6 function calls, we print out the value of a variable x again. Because this is happening, this statement is in the main function. The integer x that's being referred to will be the integer x defined over here inside the main function. Had we not defined this integer x equal to 5 inside the main function, this statement, or even these 2 printf statements, would still be able to execute, but they would refer to the integer variable x that has file scope, or the global variable x, the one we initialize to 1. Okay, let's jump into the local, into use local, into the 3 functions that we defined here. So I kept some of the comments. I should say I added some of the comments that are in the slides showing this code. So use local. This one declares and defines and initializes an integer x and initializes it to 25 inside the use local function. Now this fourth integer x has local scope, meaning it is created every time we call and enter and execute the use local function, and it stops existing after we exit the use local function. So it exists only for the time that we are in the function. As soon as we exit the function, this integer x initialized to 25 over here is cleaned up, does not exist anymore. Then we have the use static local function. And remember, we declare a variable static by using the static keyword in front of its definition. This is now the 5th integer called x in this code. And this one is static. What this means is that this variable exists from the time we start executing our program, and it continues to exist throughout, retaining its value, and it is only removed from memory at the time we terminate the entire program, not just this function, the entire program. So if you declare a variable like this integer x static, even if it's inside some function, you can use a static variable like this to remember data, remember variable values, even after you finish executing that function. And next time you come back and call this function again, execute the code in it again, you will still have the last value this variable took. However, because this integer is static integer variable is being declared inside use static local, the scope of this variable is function scope, meaning this x is only visible, accessible inside the use static local function. Finally, we have the use global function at the end. This one does not declare any variable x. It, however, does use a variable x. Now, which one could it be referring to? Well, all of the other integers x we defined. The one we initialized to 50 over here, the one we initialized to 25 in use local, the one we initialized to 5 in main, the one we initialized to 7 in the inner scope of main. None of those have a scope that extends to the inside of the use global function. So the only x we could be referring to over here, the only one within our scope, is the global variable x we defined right at the top. So let me run this, and you'll see we already discussed what the output of this code is. It's exactly the same. So we begin in the main, printing out the value of x, which refers, of course, to this x over here, initialized to 5. We then go into the inner scope, where we define x equal to 7, print that out, and that printf statement prints out x equal to 7. We exit the inner scope, are back in the main function, the outer scope of the main function, and we print out the value of x again, which shows up as 5, because this is now again referring to this x over here. We then call a bunch of functions. We call useLocal, which initializes x to 25, prints it out as 25, increments it. That incrementation happens to this same x, of course. It becomes 26, which is reflected in the next printf statement's output. We then call the use static local function. X is initialized to 50. We increment it, becomes 51. Now, so far, this is kind of the same behavior as what use local did, but here's the difference. When we call use local again, x is again initialized to 25 and increments to 26. But when we call use static local function again, its value of x is still at 51, where we left it after exiting the first call to use static local up here. So it's still at 51. We incremented, it becomes 52. And that's the difference between a simple local variable with function scope and a static local variable. Finally, we have the global. Variable. This one, I think I made a small mistake over this. Is supposed to be not plus plus x. I think we did multiply by 10 in the example, right? Yeah. So yeah. Let me just clean this up. Okay. And run this again for you. And there you go. Now, so the first time we call the use global function, we get x equal to 1. This is the global x we have up here before the main method, before the main function. It is multiplied by 10 before exiting use global for the first time. Then when we call use global the second time, x is still 10, of course, and we multiply it by another 10, and it becomes 100. And after doing all of that, in the main function, we call the printf statement again, and this one acts the integer x that is in its scope will be the integer x in the main function, so prints out as 5 again. I want to show you one more thing. So let me add another integer. Let's call it y, and I'm initializing this one to 200. Doesn't really matter because so obviously I'll be able to access this variable y out here, and I can print out its value. But what do you think will happen if I try to access y in the inner scope of main? Can I or can I not? So can I access this y in the inner scope of the main function? Question mark. Let's try it out and see. Yes, you can. So as long as I don't define another integer y in here and initialize it to something else, I can still access the variable y or any variable that I have outside of the inner scope over here. It is only when I have another variable with the same name in the inner scope that the one outside will not no longer be accessible to me. Let me try that out. So now I have added an integer y in here. You can see here local y in inner scope main is 400. That's this value over here. What about the other way around? What if I don't define y over here and instead I define y in the inner scope, set it to 400 and try to access it in the outer scope? Will that work? I can tell you, you can see right away it won't work, because you can see this small red squiggly under the y over here. That's because y is not being recognized as a variable. Already gives me a warning. Identifier y is undefined. I cannot see the variable y out here, outside of the inner scope. And if I try to execute this code, I'll get an error. So this won't work. So that's all about scopes. Please implement this, try it out, play around with it. Okay. If there's anything, if there's any other scenario that I missed that you think you don't have the answer to yet, try it out. Find out which variable is accessible from where.